So here I'm going to describe how you need to manage your data. So how are you going to collect your data to do the meta-analysis? So I'm going to talk about how you manage continuous data, how you manage binary data, and also mention that there's some tools that you can use if you need to extract data from graphs. Now, from continuous data papers, what you need is a consistent outcome measure. Now, this is often a problem. So, for example, in stroke and cardiovascular diseases, different people take different approaches to how you measure it. It can be infarct volume, it can be to do with pressure, blood vessel blocking, and various other measures. You need to make sure that all the papers that you use for your meta-analysis are using exactly the same outcome measure. So that's part of the filtering process. You can't compare apples and oranges. Blood glucose, if you're doing, let's say, a blood glucose level after 15 minutes after treatment, but some of the papers report it after 30 minutes, these are not comparable things. So you need to make sure there's good consistency. That might mean that you end up with very few papers in your study. It doesn't matter if it's 4 or 5. It's nice if you've got 30, but it doesn't have to be. You need means and standard deviations for the controlled and treated groups. Easy to find in the paper if they're tabulated. Sometimes they hide the control group results. If you've got to take it out of graphs and you've got to deal with the typical bar chart with error bars on it, then that can be difficult to do, especially if they haven't defined what the error bars mean. The data you need to store in your Excel spreadsheet needs the study name, the year of publication, the number of treated subjects, the mean for the treated group, the standard deviation for the treatment group, the number for the control group, the mean for the control group, and the standard deviation for the control group. So in total, you need each of these columns. They must be present in your data set, then you'll have a nice easy analysis. So N is for experimental. So you've got 8 columns of data. For binary, you need the number of people exposed and those not exposed. You need the number of people with events in the exposed and not exposed group. So those who are ill, those who are affected, those who are unaffected. Those are all the numbers you would usually use if you're going to do a chi-squared test. And you can also use similar techniques for diagnostic tests, but they have some added complexities for their analysis and they are a specific topic on their own. So the format is, like before, study name, year of publication. So number of events in the exposed group, number in total of the exposed group, those that have events and don't have events, number of events in the control group, number of total people in the control group. So this is easier to do, you only have 6 columns. Now if you've got data from graphs like this one, this is the diagnostic rates by ethnicity and sex for a particular disease. Doesn't particularly matter. Now if you look at them, this is why I really dislike bar charts. So the only thing that matters on this chart is the top of each of those columns and also the width of those error bars. That will happen to be for COVID-19. So I want to look and see if black British patients are having a different occurrence to others, because this was the idea that there might be an ethnicity effect within COVID. You've got a diagnosis per 100,000. Now what you need to do is get a piece of software which will look at the graph, mark on it where the zeros and the maximum values are, tell it where the zeros and the maximum values are, and then from the coordinates on the graph it can work out what the values are going to be. So if you go to the Cochrane organisation, they've got some training about how to use this particular software and also links to downloading the software. Now here is the graph put into the software, so all you need is an image of the graph. So in this case I've got a PNG file because I took a screen capture, but it could be a JPEG or a TIFF, doesn't matter what your file type is. So then you pick your scale, so you pick your 0, you pick your maximum, and then you select the points within the charts that you want. then it will give you as a little separate window, it will tell you what the corresponding y-axis value is and also the x-axis value. So this allows you to convert over the diagnosis rate to find out that the midpoint is 641, the upper bound is 693 and the lower bound is 593 for that particular column of data, and then you can extend it to do all the rest. It's a bit tedious, but it does allow you to get the data if it's not been tabulated.